all your subjects and your courses at this. And this time, I'm going to be switching to another subject or course, which is chemistry. And in chemistry, we have different branches. We have the analytical chemistry, we have the inorganic chemistry, we have the physical chemistry, we have the organic chemistry. So, and I'll be taking the organic chemistry this time. So I'm going to be taking it from the beginning. And we take it from the known to the unknown. Okay? So, what is organic chemistry? Organic chemistry is the study of carbon compound. Organic chemistry is the study of carbon compound. So the board. On the board. Organic chemistry is the study of carbon compound. Carbon is important because it can catenate. Carbon can catenate. Carbon is important because it can catenate. What do we mean by catenate? Carbon can combine with itself to form straight chain and branch chain, and it can also combine with other elements. So carbon can combine with itself to form straight chain and branch chain. It can also combine with what? Other elements. Carbon can also combine with itself to form a cyclic chain. Okay? It can combine with itself to form a cyclic chain. So that is why we say that carbon can catenate. There are other important that concerning about carbon. But let us move quickly. Let us move quickly to compounds of carbon. Compounds of carbon. So some of the compounds of carbon can be organic or inorganic. Can be organic or what? Inorganic. So if you are talking about inorganic carbon compound, we're talking about H2CO3, we're talking about CO2, we're talking about Na2CO3, and so on and so forth. So this is inorganic. This is inorganic. But this topic we are going to handle, I'm going to teach you this time, is on organic compound. So an organic compound, if we were to deal with it well, then we're talking about hydrocarbon. We're talking about hydrocarbon. 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 Hydrocarbon is the study of carbon and hydrogen only. It is the study of what? Carbon, compound containing carbon and hydrogen only. Very important. Only. Very important. So, and hydrocarbon is divided into two. Hydrocarbon is divided into two. Okay, let me just define it. It is the study of carbon and hydrogen only. Hydrocarbon is the study of carbon and hydrogen only. Okay? And I said hydrocarbon is divided into two. Hydrocarbon is divided into two. It is divided into two. Okay? They are aliphatic hydrocarbon, aliphatic hydrocarbon, and aromatic hydrocarbon, aliphatic hydrocarbon, and aromatic hydrocarbon. Aliphatic hydrocarbon deals with hydrocarbon that don't have scent or aroma. It deals with hydrocarbon that doesn't have odor. It deals with hydrocarbon that doesn't have scent or odor or aroma. While aromatic hydrocarbon deal with carbon compounds that have aroma, that have scent. Example of aromatic compound is benzene. Benzene is aroma, it has aroma. Toluene, example of aromatic compound are benzene, toluene, xylene, naphthalene, 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 etc. Okay? So, but this time I'm going to be taking you on aliphatic hydrocarbon, because that is the base or the basic of hydrocarbon. So if you are grounded in aliphatic hydrocarbon, that means you will be able to handle other work. I told you I'm going to be taking it from the known to the unknown. Okay? So aliphatic hydrocarbon now. Aliphatic hydrocarbon. Aliphatic hydrocarbon. I told you earlier that it's hydrocarbon that doesn't deal with what? Aroma. Doesn't deal with aroma. So other hydrocarbon divided into two. Aliphatic hydrocarbon divided into two. We have one saturated hydrocarbon. Saturated hydrocarbon. We have two unsaturated hydrocarbon. Saturated hydrocarbon and unsaturated hydrocarbon. Saturated hydrocarbon are hydrocarbon that have single bond in between carbon atoms. They are already filled up. They don't need addition. Rather, what they undergo is substitution reaction. They don't need addition. So, and example is the alkane. Alkane is saturated hydrocarbon. Unsaturated hydrocarbon is a compound that have a pair of bond, a pair or more pair of bond. A pair means that it has two bonds or it has three bonds. So we talk about unsaturated hydrocarbon. So when we are talking about aliphatic, it is divided into two. So and that is what we're trying to explain to you. So unsaturated has a double bond in between carbon atom. Okay? So let us quickly talk about is saturated hydrocarbon. Or we can say aliphatic hydrocarbon can also be divided into three. We can also divide it into three. We have, or we can say we can divide it into two. We can divide it into two. Or saturated hydrocarbon or saturated hydrocarbon can be divided into two. We have acyclic. We have acyclic, and we have what? Cyclic. Acyclic hydrocarbon, cyclic hydrocarbon, acyclic hydrocarbon, cyclic hydrocarbon. Acyclic hydrocarbon is hydrocarbon that have straight or branch chain. Acyclic hydrocarbon, acyclic hydrocarbon. This is hydrocarbon. This is hydrocarbon that has either straight chain or branch chain. So what do we mean by a straight chain? A straight chain is a chain. A straight chain is a chain in which there is a series of methylene groups. Straight chain is a chain. Is a chain in which there is series of methylene group. Methylene group in between carbon atom. The straight chain is a chain with a series of methylene group in between carbon atom. This is straight chain CH3, CH2, 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 CH3. What do we call methylene? Methylene is CH2. Methylene is CH2. So why do we say we have methylene between carbon atoms? Look at the structure I just gave you. If we start to analyze it, we have like this CH3, we have it to be C, we have H. So the next CH is CH2, H. The next C have another 2 hydrogen. The next one have another 2 hydrogen. The next one have another 2 hydrogen. The next one have another 3 hydrogen. Alright, so why do we say we have a series of methylene groups? I told you that methylene is CH2. Look at it. This is CH2. This is CH2. This is also CH2. 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 So when we are talking about straight chain, you have to make sure that the hydrogen that's attached to the carbon is 2, unless there's a substituent. Substituents are some group of compounds that can replace this hydrogen, because this what's named alkane or this straight chain hydrocarbon cannot be added. Hydrogen cannot be added to them. Rather, substitution can only take place. So when you want to name your compound, you have to the number of hydrogen that is attached to the carbon. So if by venture we have 2 hydrogen that's attached to the carbon, then that means is complete. But if you have only one hydrogen attached to it, that means there should be a substitute like a ketone that can replace the other hydrogen. Okay? That is what we mean by straight chain hydrocarbon. So straight chain hydrocarbon is what? A series of methyl group between carbon atoms terminated by hydrogen. Okay? So that's what terminated by hydrogen. So this is straight chain hydrocarbon. We can also have branch chain as I gave before. A branch chain hydrocarbon is a hydrocarbon in which the carbon hydrogen group have been replaced by the carbon group. The branch chain hydrocarbon, branch chain hydrocarbon is a hydrocarbon in which the carbon hydrogen group has been replaced by carbon group. So carbon hydrogen group has been replaced by carbon group. Okay? So I will give a structure now so that you can understand what we mean by a branch chain hydrocarbon. Okay? Look at this structure: CH, A, C. Okay? And I have C. On the number day, it's supposed to be CH2. I have another C here. Let us have a hydrogen here. Then I can have a C, which is CH2. I can have a C, which is a hydrogen, which is C. I can have a CH3. Okay? So here it's supposed to be taken by hydrogen. But hydrocarbon have took the place. So that's why we say we're having a branch chain. That's why we say we're having a branch chain. Then look at it. So a branch chain. So the carbon supposed to take hydrogen here so that we can have a methylene. The loop is taking carbon. And the carbon is now surrounded by what? Hydrogen. So same thing applicable to this. Carbon was taking place of hydrogen, and the carbon also took the place of hydrogen. So this is what we call the branch chain. This is what we call the branch chain. So I told you that, and the branch chain and straight chain are the two types of A cycle. Okay, so I said we have two types of aliphatic, or two types of saturated or saturated. So, and I've been able to give you the acyclic. The other one is the cyclic chain. Cyclic chain hydrocarbon is a hydrocarbon that form a plane. It forms a plane, a shape. Okay, let's just put it that way. It forms a shape which can be triangular, okay, which can be rectangular or square. It can be rectangular or square. It can be in this form. Okay, you can have it in this form. Okay, we can have it in this form. We can have it in this form. Okay, so these are what is called cyclic chain. Alright? So we quickly go straight to saturated hydrocarbon. Let's now handle it in a way that is more deeper. So we have saturated hydrocarbon, as I said before. Saturated hydrocarbon. hydrocarbon. So example of saturated hydrocarbon is alkanes. So alkane is what we want to discuss under saturated hydrocarbon. Alkane have single bond in between carbon atoms. That means there are some compounds that have double bond, while there are some that have triple bond. Okay? Or we can say a pair of bond. Okay? So when we say a pair, that is two. So alkane have only single bond in between carbon atoms. Alkanes are sp3 hybridized. Alkanes, one of the properties is that by hybridization is sp3. So what do we mean by sp3? We have the sp3. That means we have in inorganic chemistry, we have what we call sharp, the principal, the diffuse, and the fundamental. While SPGL, the sharp, the principal, the diffuse, and the fundamental. So now we notice that carbon is tetrahedral in shape. Okay, and it has the number of protons in carbon is 6. The number of protons in carbon is 6. So by hybridization, 1s joined with the p orbital, the 2p orbital. 1s joined with the 2p orbital. But p is divided into 3. You have the px, py, and the pz. ps, py, and pz. So each orbital must have two electrons. So, but p has 3. So we have the pi, the py, and the pz. Each of them is 2, 2, 2. And because there are 3, that's 2 times 3 gives us 6. So, and S is what? Having two electrons. So the S and the P are called the orbital. We have the D orbital, we have the F orbital. Okay? We even have the G orbital. Alright? So now by hybridization, according to Hund's rule, or Hund's rule, it is assumed that the orbital must be filled singly before pairing takes place. So the orbitals must be what? Filled singly before pairing takes place. Now, since the orbital is filled by the atomic number, we use the atomic number to fill the atomic orbitals. So if we want to handle the Hund's rule and the hybridization using Hund's rule, we see that we have the orbital in this way. We have the orbital in this way. We have the orbital in this way, where we have 1s, we have 2s, 2px, x, 2px, then 2py, 2pz, 2px, 2py, 2pz. So, by the first, the ground state orbital must be complete. So, we have the orbital is already filled. That means we are having 4 more because alkane have carbon have 6. We have 4 more. So from this 2s to any of the orbital must be first of all filled singly, follow the Hund's rule method. So this gives us, when we finish singly, we have this, we have this, we have this, we have this. I'm just explaining why is arcane SP3. Why is SP3 like that? So now, this 1s here, if it escapes this orbiter and this orbiter and join with this last orbiter, we say we are having arcane. If it escapes this orbiter, instead of joining with this orbiter, it refused, and it didn't join with this orbiter, and it joined with this last orbiter, we say we are having arcane. And this orbiter is called hybridized. Hybridized. You say it's hybridized. So it's hybridized, and this is true. That is not that this one is unable to pair with is unhybridized. Unhybridized. Okay? So that is what we mean by SP3. That's what we mean by SP3. So we'll be telling you what happened to other p orbitals, that's the ps and py, as we progress in this study. Okay? Now, you have to understand how arcane is SP3. The another properties or characteristics of arcane is that it is arcane has the orbitals in arcane, the orbitals has percentage. Okay? The orbitals has percentage. I will call them percentage of characters. Percentage of characters. So now we are having S and we are having P, P and P. That is why we are having SP3. S, P, P, P. Now, if you check well, we are having 1, 2, 3, 4. So if by percentage, we are having 100 over 4. 100 over 4, that means we are having 25%. So the percentage of S character is 25% for P. While the percentage of P, say this one is 25, this one is also 25, and this is 25. 25 times 3 will give us 75%. So percentage of S character is 25% because the S is really 1. And the percentage of P character is 75%. Arcane, other characteristics, other things you need to know about arcanes. Arcanes has only a bond called sigma bond. The bond you have here, C to C, is called sigma. Sigma bond. Very hard to remove or to break. Very, very difficult to break. Although, because of this sigma bond, it makes arcane unreactive. Because of the sigma bond, it makes arcanes unreactive, unlike other hydrocarbons. Right? So, arcane have a bond angle. So, arcane is tetrahedrally arranged. So, that's why we can have something like this 4. So, tetrahedrally arranged. Arcane is tetrahedrally arranged, and it has a bond angle. That's an angle. Arcane has an angle. So the angle is able to cover between the two bonds is 109.28 minutes. 109 degree 28 minutes. 109 degree 28 minutes. This 28 minutes can be converted to degree by dividing this 28 by 60. We will divide the 28 by 60 so that we can convert everything, this 28 minutes to degree. So divide 28 minutes by 60, then add the result to 109. So if we do that, we have 109 plus 28 over 60. So which gives us 109 plus 0.5 approximately. So that gives us 109.5. So the angle, the bond angle of A is 109.5. So we can also have other characteristics that Arcane possess, which is what? The bond length and every other thing. We're going to be hearing other information about this Arcane from our next video. Thank you for listening.